My first query is, if I'll ask you to divide, let's say 65 by 13, you know, and we get a value of 5. Can you tell me how we got, how we get, or what is the significance of this 5? How did we get this 5, or what is the significance of this 5? Batao? Anyone?
13 का मल्टीपल है सर 5 इसलिए.
Of course, 13 का multiple है, but you just change the sub वो language, not language, the words, but you could not explain what does this mean.
If we take 13 5 times, then we get 65. So
Yes, that's what I wanted to hear. So basically, 65 can be grouped in 13 in 5 groups. Yeah, this is what actually it is. So now, if we add anything to 65, hmm, um, if we add anything to 65, and if we then divide the number by 13, what will happen? क्या होगा? कोई बोलोगे कि बंद करे पढ़ाई करना?
फिर रिमाइंडर बचेगा.
यस, जस्ट टेल. कोई तो फटाफट बोला करो कि अगर आप इसमें, if you add 1 to 8, you will get remainder, or remainder will be 1, because all the 13 will be clubbed, and then you will be left with 1, you know, in this case. So anything I'll add to 65, it will be the remainder till the time we will add 13 to 8. And then if I'll divide by 13, it will give you remainder 0, because 13 gets divided by 13. And if any number greater than 13, then actually we have to identify that this can be grouped in 13, this will be grouped in 13, then the 2 will be the remainder. So the addition of any number will act as a remainder, and that remainder can further be uh, solved to get a remainder less than 13. ठीक है? And if there is already a number which has remainder like 67, so I know if I'll divide 67 by 13, it will give me remainder 2. And then I'll add any number which will give a remainder of 4. And if I'll add those number, what will be, what will be the remainder now?
6.
Remainder will get added. And it will be 0 once if the extra part or remainder of both of the terms sums up to 13 or multiple of 13. So it will be then 0. So this can be generalized as, if a divisor is P and Px plus R1 plus Py plus R2. If this gets divided by P, it will give you a remainder R1 plus R2. Okay. Now tell me, this is the case of addition. Okay. Now tell me, what will happen when I'll subtract 1 from 65 and then divide it by 13. Abhi kya hoga? What will happen now?
सर 12 रिमाइंडर बचेगा।
वेरी गुड। आपको क्या पता है कि हमारे पास 13 के सेट्स थे, all other 13 will not get disturbed. The last 13 will actually reduce to 12, and the 12 is the extra, and that will be our new remainder. But we will also, or we can also treat this as -1 remainder. Okay. Although -1 remainder doesn't have any physical significance, but in mathematics, we can keep the remainder as -1 or treat it as -1 remainder. So, uh, for in the case of 13, the remainder 11 is equal to remainder -2. So, 65 minus 2 will give you 11 remainder, or -2 remainder. We'll call this any extra term, but it is in negative terms. Okay? So this is our negative remainder and concept of negative remainder. All other things will go like addition that I have already explained you. The next सॉरी, आज तो हम लोग को जीपी पढ़ाना था ना। कोई बात नहीं है, ये भी खत्म करना ही है। सो लेट्स फिनिश दिस। What will happen if I'll multiply anything to a number and then divide it by the same divisor? So 65 divided by 13 gives you no remainder. That means it is divisible by 13. And if I'll multiply anything in 65, it will again give you no remainder. Okay. But if 67 gets divided by 13, if it gives you 2 remainder. And if I'll multiply anything to this, if I'll multiply anything to this, like 67 into 2. So what will happen? This is 13 into 5 plus 2. It is getting multiplied by 2. So if I'll write the term, or I'll multiply this in algebraic format, what I'll get? 13 into 5 into 2 plus 2 into 2. And since this term has 13, it will get divided by 13. And this term doesn't have any 13, so it will be the remainder. So what is happening? In case if you are multiplying something to the number, the remainder gets multiplied. Okay. So if there's a bigger number like 67 into 10, so I know the new remainder will be 20 because the remainder here was 2. The new remainder will be 20, and 20 will give you further remainder of 7 for the case of 13. So this is how we built remainder in multiplication. We'll use some few more examples here. Now I'm multiplying 65, not 65, 67 into 69. And then I'm trying to divide it by 13, and I'm asking what will be the remainder in this case. So I know the above term is 13 into 5, or I can just write 13x. I don't have to write what is the multiplier here. 13x plus 2, and then 13x plus 4 divided by 13. यहाँ पे this could be anything. X can be y also, or anything. If I'll multiply these two terms, I'll be getting three terms. Matlab we will have four terms in this multiplication. Out of these, three will be divisible by 13. Like 13 in 13x into 13x plus 13x into 4 plus 2 into 13x plus 2 into 4. इसको इससे, इसको इससे, इसको इससे, इसको इससे. So the remainder or the only term which is free from 13 is 8. So the new remainder will be 8. Now what if I am multiplying 66 and 64 and dividing it by 13? What will be the remainder in this case? So I know this is 13x plus 1. Next one is 13x minus 1. And then I'm dividing it by 13. What I get the free term as a free term is minus 1. So this is your remainder. Minus 1 remainders will lead to the remainder of 12. Okay. Did everyone get that?
Yes, sir.
Yes, sir. So, Nakshatra, tell me what was your doubt? The first question that you asked. Do you remember that?
Uh, yes, sir. Find the remainder when 51 into 53 is divided by 54.
51 into 53 divided by
54.
54. So now you can just see here. The first term is 54 minus 3. The second term is 54 minus 1. And if you will multiply all these terms, the only term which is free from 54 will be last में plus 4. Sorry, plus 3. Minus 3 into minus 1. So this plus 3 will be remainder. Okay.
Yes.
Will you remember that?
Yes.
So there was a very simple which was asked question which was asked in CAT few years ago. They asked a question like this. One seven two nine into 1731 into 1735. If it gets divided by 2, 12, what will be the remainder? So now you know 1728, or let's divide any number by 12. 1729, if we'll divide that, 1, 4, and so I'm getting 9 here. So as a B, you could have seen that 1720 is divisible by 12. Is it divisible by 12? No. I think I did made some mistake. I did make some mistake.
सर वो 54 लिख दिया आपने 52.
Oh, यहाँ 2 होगा ना? It will be free 4. Then it will be 48 and 1. 1 is the remainder here. That's why I was writing. While I was writing, I was thinking that 1728 is it's divisible by 12, whatever I remember. So this will give you remainder 1, this will give you remainder then 3, and this will give you a remainder of 7. So what I'll do, I'll multiply those remainders 1 into 3 into 7 and divide it by 21. 21, sorry, divide by 12. 21 divided by 12 will give you a remainder of 9. So the answer for this question will be 9. And this was the CAT question. Once again. So now you know how to use negative remainders also. Now let me give you a very interesting case here. Let's say there is a number 67 and it has been raised to power 72. Okay. And this is getting divided by 17. Or somebody asked you that what would be the remainder here. So I can easily see that The nearest number which is divisible by 17 is 68. 17 into 4. So this number can be written as 68 minus 1 divided by 70. And if I will raise this term to 72 power, and if I'll expand this, I can tell you how to write or how to expand any such expression. You can ask the question later someday, because that's not very important right now. In algebra, we'll be learning this. So what do you see here is that we have a negative remainder of minus 1 and it has 72 power. So since previous examples, I know that if 65 plus 1, not 65, 65, if 65 is there, sorry, 66 to the power 3 is there. And if it gets divided by 13, so I know 65 gets divided by 13, then I have a remainder 1 here. And then 1 will be multiplied 3 times. So the remainder will be 1 only. Here what we are saying that minus 1 will be multiplied 72 times. So the value will become plus 1. So basically all those remainders got multiplied and give you a plus 1 value. So it will be your remainder. And if it would have been like 68 to the power 39 and then divided by 17. So sorry, 67. It would have been 68 minus 1 to the power 39 and it is getting divided by 17. So it will minus 1 will have power of 39. It will be minus 1 only. And this is 17 and you don't have to keep writing this. This will be your remainder. So basically how we do calculate remainders of any power will be based on this logic only. Although the type of questions may vary, the complexity may vary. Like if we'll write here as 1, 2, not 1, 2, and 104, 106 to the power 212 divided by 17 will give you what? Okay. If such question is there, so I'll try to reach 104 only, sorry. 104 to the power 212. So I'll try to reach what will be the nearest number of 104 which is getting divided by 17. So I know that 17 into 6 is 102. Okay. So if I'll divide or we can keep this number as 17x plus 2 to the power 212. If we'll make something like this, then I know then you will also think that this particular algebra will have only one term which is doesn't have x, and that will be 2 to the power 212. So this particular problem reduced to this, that if your power is 212 and the remainder left was 2 to the power 212, and if it gets divided by 17, what will be the remainder? So this is how we keep shortening the divisor. So now I know that 2 to the power 4 will give you 16, which is close to 17. And if you draw 2 to the power 4 inside, you will be left with 53 outside. And then we can again write this 2 to the power 4 as 17 minus 1 to the power 53 divided by 17. And I know this will give you minus 1 to the power 53, which is minus 1 divided by 17. And finally, what remainder you got is 16. So this is how we solve all the power-based question. In earlier papers of CAT, this used to be a good, this used to be a regular choice for question setters. But since last many year, no such problem is appearing in the paper. But yes, it will help you in solving many other question, not direct one, but other question. And if they ask any questions like this, if you'll use just these small basics and essential, you'll be able to solve the question, whatever will come. Okay. Now let's talk about division. So what happens when division is being done? So let's say I have a number 420. And if we are dividing the same number by 50. So what is the remainder here?
2.
20. Very good.
So सिर्फ
And
2 नहीं होगा,
क्या चीज?
सिर्फ 2 रिमाइंडर नहीं होगा, 0 0 तो कट जाएगा ना.
यही तो मैं तुम्हें बताना चाह रहा हूँ, वेट करो।
अच्छा अच्छा.
अगर आप डिवाइड करोगे 50 से, तो 420 को डिवाइड करोगे तो यहाँ 8 टाइम्स में इट विल बी 400. इफ यू लेफ्ट विथ 20 एज रिमाइंडर ना, है कि नहीं?
Yes.
बट द मोमेंट यू simplified the fraction, your remainder got changed. नहीं, अगर like you did, if you reduced the number and you will divide it by अठारह, what have मतलब actually while reducing, what exactly you are doing, just tell me.
So
What was
0
the
0 कट काट देना.
नहीं, वो तो हमने काट दिया ना, that because it was drawn on the paper. What we are visualizing here, what is happening?
So we are dividing numerator and denominator with 10.
Yes, by 10. So if I'm dividing it by 10, the remainder also gets divided by 10. Here our remainder is 2, which is 20 by 10. So if we'll simplify, if we will simplify, the remainder will get reduced. ठीक है? And that reduced value, if you have the reduced value, you can find the actual remainder. So in some cases, what you will find, like if someone is asking that, what will be the remainder when 5 into 23 into 57 divided by 100? If somebody asked that, okay, or let me write it here, 21. What will be the remainder here? So one way is to calculate, and find the last 2 digits. That will be the remainder. Second way, if I am saying 5 and 100 here, if we'll reduce these two terms by 5, so now in with the help of 20, we can find the remainder. So the above term is 20 plus 3 into 20 plus 1, and it is being divided by 20. So I know that all the multi terms will have 20 in itself. The only term which is free from 20 is 3 into 1. So 3 by 20, the remainder is 3. So if the remainder is 3 here after reduction, after reduction by 5 or dividing by 5, after dividing by 5, the remainder is 3. So before division, it what it will be? I
15.
will reverse multiply it. Yes, 15. So this concept you will also use frequently. So what I did, I actually I have shown you all the type of operation that can be done on a number and what remainder you will get. Some special cases to mention here is, again, it will be based on the concept that I have studied only. The some special cases is like if you want to continue the same remainder, like 84, 86 when divided by 12, it gives you remainder 2. So if I'll add any number to 86, which is divisible by 12, it will give you same the remainder the same. Basically, my point is that these small things that I have taught you today will be used many places at many places. So just try to write it down on or not about this particular concept only. All the number system concept you should write at one place and then try to solve all the difficult questions or questions from number systems. And you will find everything that I have taught you is being used to solve the question. There is no alien question in number system. Although they might seems like alien, but they are not. They will be absolutely solvable by solved by the concept that I am teaching you. So this is all about remainder. The example also cleared the doubt of Nakshatra. Now I'll finish this lecture, but I'll start GP because last time, in last class we have studied AP. We need to finish GP also.